Hi, welcome to another Teardown and Repair video. What I have here is an Epson PowerLite 84 3LCD multimedia projector. The problem of this projector is that it does not power on. But you do hear a faint click sound every time the power plug is plugged in. So I know at least that this is not a blown fuse issue on the main input side. I will need to open it up and see if I could figure out what's going on. This projector is fairly modern, although it had been discontinued for a while, but I believe it was probably built just 5 or 6 years ago. We can later take a look at the date codes on the components inside to confirm. So this color projector uses 3 separate optical paths for each red, green, blue chromatic component, and then the light is combined together to form the final image, and hence the name 3LCD. So this is probably best illustrated here in this product manual, product brochure rather. So so this is the product brochure, and here is the image I want to show you, the picture I want to show you. So basically, as you can see, that the white light is separated into 3 color components, and each color component passes through an LCD which modulates the intensity of that particular color. And then the 3 color components are combined to form the final image and projected onto the screen. So this is different than the Smart UT55 projector that I did a teardown with a month ago. If you want to watch that video, you can follow the link I provided down below. And in that projector, it used DLP, which is digital light processing technology, which uses a micromirror device that rapidly modulates the intensity of each color passed through a color wheel and generate a monochromatic image sequence in quick succession at a rate higher than we can detect flickering. So through persistence of vision, we see colored images being projected. Anyway, let's proceed to the teardown and see what we can find inside. Okay, so let's see how many screws we have to remove. Oh, by the way, if you want to see it, here is the rear panel, and it has 2 monitor inputs, S-video and the typical video and RS-232 monitor output. And it has a LAN and the USB control. So let's take a look at how many screws we need to remove, and I can already see that we have quite a few. Okay, here are all the screws from the bottom. Hopefully we can open it up. Let's take a look. And let's see if, oh yes, the side is still not. I think here's one more screw. I didn't want to destroy that. Let's, okay. So we're in. Okay, so there are 2 cables connected, so I need to disconnect that. One is for the switch, I believe, and the other one is for the cable for the top, these buttons. So as you can see, this is what we see inside. Now, the first thing I see it's going to be a little bit difficult. Hang on, let me just remove this so it doesn't get in the way. So as you can see, the inside is quite compact, and we have to do a lot of, unfortunately we'll have to tear it down quite a bit before I can get to the components I want to see. And now we're in, and I actually just remove these screws so that I took these IR sensor out of the way. I was hoping that I could see the power supply here. Well, it is part of the power supply. I think it's the ballast. And as you can see here, these wires are the ones coming in, and I assume that this is the high voltage coming to the lamp itself. Now, here we have this very compact board, and you can see there are 3 flex ribbons here, and so there's probably some boards underneath, so we'll have to take a look. But for now, I don't want to take it apart any further yet. I just want to try to power it on again to see what the symptom is, and hopefully I can take some voltage measurements. And the one thing tricky is that here is the top, and you can see this thing is there is a connector here, and I think that everything has to be connected somehow here before it can be powered down. And if you look further back here, actually I'm not sure if you can see, let me move. So further back here, and we have this momentary switch right here. Okay, so this thing needs to be it's designed such that when the lid is open and this one is disconnected, so in order to operate this, we have to make sure that it's engaged. So I'm just going to use an alligator clip to permanently switching that on for the time being. And as far as this thing is concerned, that this little connector here is the controlling the is for the hood. So when it's closed, you know, the lamp's supposed to be powered down. But right now we're not too concerned about that. We just want to see if we have any kind of voltage coming out from the power supply, and or anything that coming into the power board, into the main board rather. So let me hook that up, and we'll take some measurement after it's powering on. So let me do that. Okay, so now I just hooked that back on, and as you can see here, the ribbon cable is a little bit short, so I have to have this lid up here. But now I also plugged in the power, and still as before, there's nothing going on. But I can actually hear a little bit of well, when the first time the plug was plugged in, I can certainly see a little tiny spark, which means that's quite normal. It's so I know the fuse is not blown. But now let's see if we can measure any voltage here, and I'm going to put it right here so you can at least see the meter. To measure it, I'm going to just use a ground. Since I don't really know where things are, I'm just going to poke some of the pins here, and so some of these has to be a power pin of some sort. So there's nothing I can see on these ends, and the light is not coming up either. So if I press the button here, nothing's going on. Okay, well there's some, okay, that might just be a, so the fan voltage, nothing is there. So it looks like definitely we have a power supply issue. And one thing I want to see is, I was hoping, okay, let's put it here so we can still see it. One thing I'm pretty certain is that this power supply, the reason I removed that was the cover before was I was hoping that the power supply somehow is right underneath, but it's really not. So this one seems to be coming from the power supply, which means we have to take this out and investigate further. But the first thing is that I would assume this would have some power, but it doesn't. So it looks like the power supply is totally dead. And I was, well, hopefully, the power supply didn't take anything out with it, because if it did, it's going to be pretty much impossible to repair this kind of thing, especially we don't have a diagram of any kind. So, but before we do that, let me just unplug this power supply so we don't damage anything. And let me unplug this ribbon cable here. Okay, so let's just move this out of the way, and let me see, and let's take a closer look at the circuit while we have it. And most of these projectors, the internal construction is really tight, and because they have to cramp so much in here and to meet the thermal profile, so sometimes it's extremely difficult to service. But we'll see. Let's take a look at the top board here, and as you can see, all these chips are Epson stamped, so we don't know what they are, but they're probably some type of dedicated processor. And so we don't have too much up here. There's some flash memory, and we'll have connectors for our power and the fan. So let me remove this top board and see what we have underneath. And I suspect we can find something just because we have the 3 ribbons here. So let me unplug all the header wires. And it should be pretty straightforward to figure out where things are. So I'm not too concerned about not able to figure out where things plug in afterwards, because these are pretty well labeled, and also given the length of the cable, it should be pretty easy to figure out. But if not sure, we should label them. Okay. So now this board is off, and also I took the screw off, and on these ribbon cables are a little painful. I just want to make sure we don't damage them in the meantime while we're trying to figure out what's wrong with the power supply. But even though I didn't have to take this apart, but I definitely want to take a look underneath this board to see the construction here. So we kind of have to, unfortunately, take this apart. Okay, so let's see if the tweezer can help. It may or may not. So, okay, so this one is actually coming out quite nicely. I'm not sure you can see this, but the one on the right-hand side is coming out. Let me turn off the multimeter first, because right now it's not doing anything. Here we go. So, yeah, it's not very easy to take these off, and probably going to be pretty hard to put them back too, unfortunately. That's just how these things are. Okay, I had to remove one of the screws back here, and now I was able to take this 3 ribbon cables all out, and we should be able to pop this right up. I can feel it's really loose, so I'm pretty sure that yep, so this now can come out nicely. Now of course I have to later on put it back. That could be challenging, and it doesn't make it, okay, they don't make it easy. So it seems to be another wire connected somewhere here. Hang on. Okay, no, maybe not. Okay, ta-da! So here we are, and I'll just I'll show you the other board in a minute. But right now, let's see what is underneath. So underneath here, as I've shown you from the brochure before, these I suspect are the 3 LCD controlling circuitry, and it makes sense because here, everything inside these inside this cover are the optical path for the RGB components, and then they're combined here via these 3 LCD chips, and then finally comes through here through the main optical path through the projector. Okay, so that all makes sense. And so what is here is that looks like our lamp right here. So we can also take a look at that. But right now, let's while we still have this out, let's take a look at this board here. And let me just unplug that. So this is our board on the back side, and again, it's a Epson branded board and branded chip, and nothing terribly exciting. To be honest, I'm not very familiar with the projector circuitry, so I have no idea what these chips do here, except for, you know, they are doing some kind of processing and stuff like that. Anyway, that's pretty cool, but that's not our main problem here. Our main problem we need to figure out is the power. So unfortunately, the power is all underneath this brick here. So in order to get that, we need to take this further apart. Now, before I do that, I just want to put this back on again so that we can make sure we don't miss anything. So now I think I'm going to remove the top portion of this ballast, and as you can see here, we have actually a vertical board here, and that's also for the ballast controller board. And I can already see, if you take a look from this angle, you know, you will see the power supply board underneath. Unfortunately, I think there's really no other way we can get to that board, so I will have to take this apart right now. And as you can see, they really don't make it easy. So this one, I just took this apart, and finally I was able to free the bottom power supply. And as you can see, that the power supply itself actually is encased. So I will have to do a little bit more work to actually get to the part we want to look at. And of course, it's not even guaranteed that we'll be able to find what is going on. But you know what you're gonna do. We have to be able to access the power supply in order to definitively tell what is going on with it. So and also the bottom, one thing I don't quite like is also everywhere it seems it's bolted. So we will have to remove some of the this shielding cover before we can access the power supply. So let me work on that, and we'll be back when we get to the actual board. Okay, so that's a lot of work. I think I finally got this out. So let's see here. Yep, I finally took out the power supply. And just by the look of it, it looks relatively simple. I mean, there really isn't anything to this power supply. And we do have a fuse here. I wanted to check that to see if that is blown, because here is where power comes in, and here is this is cable going out. So if the fuse there is blown, then we definitely would have issue. But otherwise, this power supply looks pretty simple. Now the power, you know, you don't see any MOSFET up here because they're all tucked down underneath. Now this poses another problem. So if, let's say, if some of these MOSFETs are bad, or bridge rectifier is bad, and changing them gonna be a little bit of a challenge, because I have to, you see here, this board is actually, I mean, this heatsink side is actually soldered onto the board, and these things are actually already have the thermal compound, so it's gonna be very challenging to service this board. So let's hope that's not a problem. But so let's take a look at our fuse situation here. So the fuse, you probably can't see this. This fuse here, that is corresponding to that 2 pin. So I'm just gonna take out the multimeter and to see if we have any continuity there. So let me just make sure one more time. And there are 2 pins here. Yep. So the fuse looks like it's okay too. Which is we're kind of like down to a rabbit hole here. You know, let me power this on one more time. Now I need to be very careful because now we have this all over the place, and but I think we should be able to power it up. And this fan actually is connected to here, and I don't know if it's necessary to connect it to have this thing running, but it doesn't hurt. So let me connect that back here. Oh, you can't see, sorry. I'm just talking about the fan here. So there was a fan that is on top of the power supply, and I'm basically putting that back in circuit. So just to make sure that that does not impede the operation of the unit. Now I'm gonna again hook on these. So this is why servicing this is kind of painful, because now I need to actually put this ribbon cable back on to see if we can figure out what's going on. I don't know if it is necessary to have this ribbon cable when we are diagnosing the power supply, but because the switch is on here, why can't I get it in? Okay, so I need to push it down, pop it out rather. It's because of the switch is there, so so I think we might need to at least have some of these hooked up, but I don't know because we don't have operation manual. So I will just leave it open like this, and I'm gonna hook the power supply back on in 1 second. Now I just want to show you something. So basically, as I mentioned before, here is my the power cord here, and I just want to show you that when I plug it in, as you can see here, it does start drawing at least a detectable amount of power. Okay, so now I unplug it. See, this thing goes back to 1, and I plug it in, and you can hear a little zap, and it goes to 2. So now I'm gonna leave it plugged in. So definitely the power supply is working. Well, it's not working, but it's connected. So we just don't know what the heck is going on here. So let me see if we can move this a little bit. Well, right now we're live, so let me actually hang on. So working on this kind of unit with this kind of tight internal layout is kind of unfortunate, because it's that much harder to experiment around. All right, so now I plugged it in. So let's be very careful and see if we can find anything. So now I put it on AC. Let's just rest it up here so you can see the. So as I mentioned before, this is where power comes in. So I suspect if I probe here, we can see. Yep. So you can read 120 volts. So that's not a problem. And however, we don't see anything going out. So I don't know what the voltage of this thing is. But just given that we have some wires here, at least I can see. Oh wait, we do. So here we do have minus 158. I'm not sure. Does this have a reflex there? So let's put that up here let's see, up here maybe. Okay, sorry about the angle. There's not too much space to put. Okay, here is probably better. So I do see 158 volts here. Okay, 158. Oh, let me just, sorry about the angle here. So 158. So we do have the, well, that makes sense. That's the rectified voltage, and this is a big cap. So let's see if we have any luck on the output. Whoops, I just kicked my tripod. Nope. So there's nothing coming out. Wow, that is interesting. So that seems to me something is horribly wrong with this switching power supply. So let me just poke some, I have no idea what I'm poking here, but I just want to see voltage anywhere. So yeah, so that's a, I think it's a diode. It does have voltage. And let's see, this diode here. No, so that's the output diode. So it seems like this power supply is not oscillating. So let me disconnect it again and see what we can do here. By the way, so as you can see, sorry, it's yep. So the light up here should have lit up as soon as I plugged it in, but it didn't. So and of course nothing works here. So so that was the symptom all along, and now at least we know something seems to be horribly wrong with this power supply. And hopefully when the power supply went, it didn't damage anything else. And given the high complexity of this unit without any circuit diagram, it's virtually impossible to figure out what is wrong, and if it's not the issue with the power supply. So now let me disconnect the power here. So let me disconnect it, and we will take a look further. Okay. So now I disconnected. Let me just disconnect it here as well, so we don't accidentally pull this ribbon cable. Because I don't know why they don't design it to be a little longer. Because if it's a little longer, at least it's much easier to service this without having to bump into a lot of things. Okay, so now we should concentrate on this power supply. And to make matter worse, as I mentioned earlier, this power supply is actually very hard to service because, let me just unplug the mains power. By the way, I already disconnected the mains. Because number one, there are things just soldered on here. Number two, number one is things soldered on here. Number two is everything, all the components are on this bottom side, and this actual shielding is actually soldered on it. So there's no way for me to, well, I mean, I guess if I know definitively something is wrong, I could desolder that. But right now, let's just, what I can do is just to poke around and see, get some readings to see if the components are anything obviously wrong with the component. And let me zoom out a little more so you can see my multimeter here. Let's see. This is annoying. If I put it here, yep, we can read just about reading. Just able to read that. So let me again put on the diode mode, because I do know we have quite a few we have quite a few bridge rectifier here. So I want to, actually these are not bridge rectifier. This one is a bridge rectifier. Sorry, this is a rectifier, and these are some MOSFETs. So I wanted to at least see if the MOSFETs are good. Okay. So MOSFET. Oh, I know why, because this is a, let's put it on a diode mode. Okay, hang on. So that looks reasonable. Let me just see here again. That's a diode drop. Oh, sorry, that's a diode drop. Diode drop, so that's between drain and the source. There's a parasitic diode, and so that looks okay. So that too looks okay. And how about this one here? I don't know which one is which. Probably here. Yep. So these all look okay, and it's just the bridge rectifier here. By the way, you know, this thing has some coating on it, so sometimes it's you have to really poke it to get it to work. So the bridge. Okay, here we go. Yep. So the bridge rectifier looks okay too. Well, we have a fuse here. I didn't check that yet, but I think that fuse is okay too, because we did get some voltage on this capacitor. So I'm running out of ideas. Let's start measuring something here. Let's try the resistors. I'm really puzzled right now because yeah, that's fine. That's fine. And wait a minute. Oh, looks like we might have some issues here. So that resistor, let me just put it here. Let me make sure I can measure it. So that looks like either a 2.2 ohm resistor. So let's move it down a little bit. See what I'm doing here. So this resistor here. If we can focus, let's zoom out a little bit. This resistor here is a 2.2 ohm resistor, but I'm not getting any reading. I can't measure anything out of that resistor. So just to make sure, let me try something different. Yep, not reading anything. And let's see this resistor. Sometimes they have some coating on the leg, but every other, this is a 1K, reads just fine, and everything else reads fine except for this resistor. So let's take a closer look. I don't know if that is the problem, but nevertheless, let's take a closer look. I'm not sure if you can see this. Did you see here? So if you look carefully, I think this might just be it. Okay, so my camera can't really zoom that in. I'll take a picture of this and show you. But here, there's a black part. It looks like something just, either it burned or chipped off. But that could be the issue. I mean, because what else could it be, right? So everything that we measure has, so if you look at here, this is a meter, again, meter, okay? So if we measure this one, right? So this one, for example, sorry, you can't see, let me do this. So if we measure the one above it, we can read something, 0.5, okay? And if we measure this one, there's nothing, see, nothing, nothing. And if we measure this 1K, again, we can see something back here. And this one's nothing. So I reckon that definitely has some issue. Well, the only way to find out is to take that resistor out and solder another one in. Unfortunately, as I mentioned earlier, in order to get to that resistor, the bottom pads, I have to take the whole thing apart. And I'm not even sure if that is the actual cause, because I don't know what that resistor is doing there. Just given the proximity to this MOSFET, it could be a current sensing resistor, but I'm not quite sure. So what I'm going to do is I'm just going to try to find a 2.2 ohm resistor and solder it on top of this. So at least we can test whether or not that's the actual issue. So let me do that, and we'll be right back. Okay, I looked around. I do have this 2.2 ohm resistor. I took it off from something else because right now I can't find it. But if that's, that should be good enough, at least to see if the power supply is working. Unfortunately, my solder station is in the other room, so right now I just get this little iron. Hopefully it will do the job. I'm going to tin it a little bit, and hopefully it will do the trick. So let me put some flux on it. And so what I'm going to do is I'm going to, this is going to be a little tricky here. So you might not be able to see because the position is really awkward for me too. I'm just going to try my best to get this resistor on, and then we can test. Go a little further. Okay. I like that sound. It means it's okay. That side seems to be okay. Oh no. Alright, so this is really difficult to solder. Okay. Yep, so now we got that side. And now let's come to this side. I'm going to push it down a little bit. Okay, so that is plenty of solder. Not the best soldering job, but I think it will be alright. So now we doubled it up. That's not an ideal way to solder, and ideally you should take that the old resistor out, but as I mentioned earlier, I don't even know if that would resolve the problem. So let's just double check here, and we have the thing here, and we should get, yep, somewhere about that. And so that should resolve that resistor issue. So let's zoom out, and I'm gonna power it on again, and to see if we see any difference. Yeah, worst come to worst, it would just be not working. But at least we're a step closer, because that one is definitely blown, as you saw. So now let me just plug this in. Okay, and again we'll be very careful, and I don't want to just accidentally touch anything that they shouldn't be touching. So let's leave that here, and again I have to put this ribbon cable back in. That's a big pain in that. Okay, so let's put this back in. Okay, is it in? No. Okay, now it's in. All right. And I still have the fan on the back. So let's put it here. And I still have the everything else hooked up. So let me just make sure that there's nothing. Okay. So now let me hook this on. So again, we have the power meter here. So let's put it on. Oh, did you see that? Did you see that? So it's drawing 7 watts, and that light is on. Wow, that is different. At least it's. Hang on, I don't want to. Let me try power it on. Whoa. Wow. Wow. It's working. It's working. So, don't know if you can see this, but the light is coming out of here, and it looks like it's doing something. Yep. So now actually I want to power it off because I don't want it to, because it's not proper. Wow, did you see that? So now it's actually projecting something out. Very, very cool. I was not expecting that, but it all seems to be just that little resistor. Okay, so now, wow. So now let me power it off. And we will assemble everything back. And this is really one of a kind. I mean, I guess the failure mode is really interesting because normally, so let me take this off and I will show you what the problem was again. And as you can see, that resistor, I cannot believe that resistor was all that was wrong with the power supply. But and you can see the burnt mark underneath. So we still don't know what happened to the original resistor, whether or not it's not rated properly or just somehow the resistor itself was faulty. But just by powering it up for a brief moment, it doesn't seem that that resistor is overly stressed. So probably there's some manufacturing defect that caused that the carbon film to become dislodged, and that's created an open circuit. So let me now move, just right now it's a big mess here, but I wanted to let's reassemble everything, and we hopefully have a working projector. And now I put everything back together and only have one extra screw. I guess it doesn't really matter, and at this point I don't want to just open it up again and try to hunt down where I did not put the screw in. So let's test it out. I moved the setup a little bit closer to the wall so you can see the projected images more clearly. Let me turn it on. And it should just take us a few seconds. As you can see, you already can see the projected image on the wall. I just need to set the focus a little bit, and we can adjust the to zoom it out a little more, because right now the range is really close, so the image itself is quite tiny. But I just wanted you to see that actually this one is fixed. Now the black line in the middle is actually my wall. It's on my wall. It has nothing to do with this projector. So it looks like the everything seems to be working just fine. And let's see here. Yep. So everything seems to just be working fine. And of course, we can always, adjust the keystone here. Not a problem. And so it looks like we totally fixed the projector. So hopefully you learned some troubleshooting techniques from this video. Well, I have to say it was a really lucky fix because the component failed was just the open circuit resistor and nothing else. Most of the modern power supplies have built-in built-in protection mechanism. So when a malfunction occurs, typically the output is disabled and the failure is contained to within the power supply itself. But I have seen more catastrophic power supply failures that caused the damage to propagate throughout the system. But most of the time, though, a power supply failure is far easier to fix, even if it involves changing multiple components such as power devices. So anyway, I hope you found this video interesting, and please don't forget to give it a big thumbs up and subscribe. I will catch up with you next time.